In this tutorial, we will see how to design a horizontal NEN type fixed tube sheet heat exchanger. First, create a new project. You can also open an existing project and add this heat exchanger to it. In this case, we are creating a new project. Click on the project bar in the Project Explorer to make it current. Now select the submenu option Heat Exchanger available inside the top menu Equipment. This will open out the Heat Exchanger configurational dialog box. Fill in the relevant details in this dialog. Please ensure that you select the appropriate code, tema class, service, front-end type, rear-end type and support. Click on the Dialogs button OK. The equipment will be added to the currently selected project in the Project Explorer with the equipment name NEN type HE. If it isn't visible in the Project Explorer, then click on the project bar to expand the tree. You can see that under the entry NEN type HE, a tree list is generated wherein various details for the equipment can be seen, defined and/or updated. Before we move further, it is important to understand the various parts of the equipment tree contents in the Project Explorer. In case you haven't viewed the other tutorials in this series, we suggest you view them for better understanding of this tutorial. Click on the entry NEN type HE, which by itself is a major definition entry, wherein the major configurational or dimensional details are defined. Update the contents in the Properties window. The next step is to input design data information. For this, locate the tree node entry design data and then the shell design data within. For heat exchangers, one has to enter shell side and channel side design data. Each side design information contains sub-entries to feed details for various conditions. First, enter the shell side operating and design data. Please note that the pressure units are kgf per square mm gauge. Having updated the operating design information in pressure and temperature operating, proceed to updating of design data information in pressure and temperature design 1. Click on radiography and update the appropriate entries therein. Update the corrosion allowances information as shown. This process completes definition of the shell side design data information. Now proceed to defining channel side tube side design, for which you'll have to update in the subtree entries in channel design data. The next step is to apply material of construction for various components. You can define this in the common areas, thus saving time required in defining the material for each individual component. The definition of material is covered under the Equipment subtree Material Specs in the Project Explorer. In following the entire above process, we have defined the equipment configuration, its overall dimensions, design data like pressures, temperatures, etc. under various conditions, radiography, corrosion allowances, etc. and have defined material for the various components. While following the above procedure, you may have noticed that you have done minimum definitions or entered minimum inputs. The other entries have been left blank or empty, and the software will select appropriate values for them. At this stage, let us proceed to the designing of the equipment. First, you have to ensure that the equipment you want to design is the current equipment in case there are multiple equipments in the project. To make any equipment the currently selected one, click on its equipment tag or any item in its tree. Now select the submenu Design Equipment in the top menu Design Model to begin the design of the equipment. While the equipment is designed, any design warning or errors that occur are displayed in the Errors and Warnings window. The warnings are displayed in black color and any severe errors are displayed in red. In case of warnings, the user can review them and take the necessary corrective action if required. While in case of errors, the user has to take the necessary corrective action for equipment design to proceed further. You'll notice that there are warnings for some objects and an error in tube sheet front object. For the moment, let us ignore the warnings and concentrate on the errors depicted in red. The warning number 1230 indicates there are excessive stresses in the channel exceeding the allowing stress. To bring these stresses below the allowable limit, the increase in thickness of required tube sheet is very high. Therefore, under such a situation, review of the heat exchanger configuration is essential. Now click on the main shell object and generate the report for it by selecting the submenu Code Report from the top menu Create Report. This will display the design report for the main shell object. You can use the right side scroll bar in the output window to scroll the report. The design outputs are displayed in an area called the output window, which is a tabbed page. The top of each output window has tab entries, and on clicking each tab, you see the output for that particular design condition. You'll also notice that the required nominal thickness of shell is 18 mm. Similarly, you can click on the channel shell front object and generate a report for it by selecting the submenu Code Report from the top menu, Create Report, and study its design output. The report shows that the required nominal thickness is 16 mm. You can now click on Tube Sheet Front and create design reports for it. Since there was an error in designing this item, it won't be possible for the software to generate design reports for it. While designing fixed tube sheets, when there is a failure due to excessive stresses in the integral shell and or integral channel shell, the options available to the user are listed in UHX 13.511. According to this clause, the design shall be reconsidered by using one or a combination of the following three options. First, increase the tube sheet thickness. Second, increase the integral shell and or channel thickness. It is permitted to increase the thickness adjacent to the tube sheet only. Third, perform the elastic plastic calculation procedure as defined in UHX 13.7. The options in setting tube sheet allows the user to preset any of these three options or a combination of these options, and the program will accordingly redesign and evaluate the tube sheet thickness, shell thickness, and or channel thickness. Now to resolve the error, click on the subtree Settings in the Equipment node tree in the Project Explorer. Thereafter, update the setting pertaining to the tube sheet designing under Setting Tube Sheet. Select True for Auto Adjust Base, which allows the program to automatically adjust the shell and or channel shell thickness that are integral with the failed tube sheet, thus ensuring the adequacy of the entire tube sheet joint configuration. Having done this setting, you can now proceed to redesigning of the heat exchanger by selecting the sub-menu Design Equipment in the top menu Design Model. Click on the main shell object and generate the report for it by selecting the sub-menu Code Report from the top menu Create Report. This will display the design report for the main shell object. You'll also notice that the required nominal thickness of the shell has now changed. Similarly, you can click on the channel shell front object and generate the report for it by selecting the sub-menu Code Report from the top menu Create Report and study its design output. The report shows the required nominal thickness. Thus, the thickness of the shell and the channel shell have been increased to meet the adequacy of the shell tube sheet joint requirement. The solution achieved here may not be economical and we may need further reworking. The economical design can be achieved by using higher shell and channel thickness near to the tube sheet to shell junction areas. As a matter of interest, let us perform one or more change in the settings for tube sheet design by selecting Elastic Plastic Analysis of the tube sheet joint configuration. For this, the setting Perform Elastic Plastic Calc set to True. This will automatically force the software to do the additional calculations. Having done the setting, you can now proceed to redesigning of the heat exchanger by selecting the sub-menu Design Equipment in the top menu Design Model. After redesigning, you can review the calculation reports for tube sheet shell and channel thickness and note the results. For addition of nozzles, kindly view other tutorials in this series. Now we quickly demonstrate a method to design the same heat exchanger with local shells near the tube sheet junctions of higher thickness. The central part of the shell is of lower thickness. Please ensure that you select the appropriate code, tema, class, service, front end type, rear end type and support and other details. The most important selection is multi-shell selection, which should be set to true. After you fill the details as shown in the above dialog, click the OK button. Before we proceed to the designing of the equipment, we need to do finer modifications to certain objects or items in the model. The main shell assembly shows three shell items, namely main front, main shell and main rear. The tube sheet design will modify the items main front and main rear only during the check for tube sheet joint design adequacy. This may change the thickness of these two small shell sections adjacent to the tube sheets, leaving the central large piece, main shell, untouched. Click on the subtree settings in the equipment node, namely NEN-HE of Tree Project Explorer. Update the setting pertaining to tube sheet designing. Design the equipment and check the results for the various components. This completes the tutorial. Hope you enjoyed the features of our software CademPVD. For software inquiry, email us at cadem@vsnl.com. You can download a trial version of our software from our website www.cadem.in. You can subscribe to our YouTube channel www.youtube.com/cademchannel. You can also follow us on www.facebook.com/cademindia and www.linkedin.com/company/cadem.